Welcome to the lecture, guys. In this lecture, we are going to continue our solution on most important question from the Irodov itself, which may come in JE Advanced or JE Mains. So it's part 2 of the gravitation. We are continuing on gravitation itself. My name is Anmol Kumar. I am MTech in Aerospace Engineering from Indian Institute of Science, Bangalore, and your instructor at iitpathshala.com. So let us start with the lecture. Now, before going into the lecture, guys, you can call me or you can contact me on these two numbers. You can give free examination on my site. Now, let us start with the lecture. Before going into the lecture, guys, please like, share, and subscribe my channel, and don't forget to hit the bell notification icon as well. Guys, let us aim for 100 likes for this video for my effort, as I am not giving you any false information regarding Irodov itself. So there are hundreds of questions from Irodov, but only few questions will be screened out for IIT JEE mains and advanced. I am giving you all those questions only. Okay guys, so let us start with the lecture. You can check my previous video on Irodov, which will be under the description itself. You can check out my other videos. The link will be under description. Okay, so let us start our lecture with this particular problem over here. So now, using the conservation law, you have to demonstrate that total mechanical energy of a planet of mass m moving around the sun along an ellipse only depends upon this semi major axis a. Okay, find the energy as a function of a itself. Okay, so the question will be coming something like this: mechanical energy of a planet of mass m moving around the sun in an elliptical path is independent of semi-major axis but directly proportional to semi-minor axis, directly proportional to semi-major axis, and independent of semi-minor axis, directly proportional to ratio of semi-minor to semi-major or semi-major to semi-minor, or product of semi-minor and semi-major axis, or none of above. Okay guys, so let us first draw the diagram itself to evaluate our problem. So this is my sun. Let us have the mass of sun as capital M. This is my small planet of mass m. It is going with a certain velocity v, and it is at a certain distance r away from my sun over here. Okay, so it is at a certain distance r away from my sun over here. I am having this farthest distance as r2, and this particular distance which is very near to my sun as r1 for the calculation perspective itself. Okay, now what I will be doing is I will be writing the equation of energy because I will be needing it. Okay, so minus g m m upon r2 plus 1 by 2 m v2 square. Let us have the energy equation for the other end also, which is as follow. Okay, nothing fancy about that. Now, from the conservation of angular momentum, you know that m v2 r2 equal to m v1 r1. Now, if you go back to the diagram itself of the ellipse, you know that your semi major axis is nothing but a itself. Okay, and from the diagram, comparing both of the diagrams over here, I can say that my a is nothing but equal to r1 plus r2 upon 2 itself. Okay, now what I will be doing is I will be writing the equation over here: r1 plus r2 upon 2 equal to a. So this is my equation number 1, this is my equation number 2, this is my equation number 3. Okay, so what I will be doing is I will be eliminating all the unnecessary variables. That's how we do the problems, guys, as I was telling you in the class itself. Okay, eliminate the variables as much as variable you can. Okay, so now what I am doing over here is using the equation 2. I know that v1 will be certainly equal to v2 r2 upon r1. I am putting this into this equation over here. Okay, so minus g m m upon r2 plus 1 by 2 m v2 square equal to minus g m m upon r1 plus 1 by 2 m v2 r2 upon r1 whole square. Now just use mathematical simplification to solve this. G m m r2 plus g m m r1 equal to 1 by 2 m v2 square r2 square r1 square upon r1 square itself. Okay guys, fine with that. Now you can more simplify it into the following form: m v2 r2 minus r1 r2 plus r1 upon r1 square. Now you know that R2 and R1 is related to A somehow. Okay, so that you have to keep in mind. That's why I was doing mathematical algebra simplification over here. Okay, you can simplify this left hand side also. You'll be having G M M as common, R2 minus R1 upon R2 R1 equal to 1 by 2 M V2 square R2 R1 then R2 plus R1 upon R1 square. Okay, you can eliminate the unnecessary guys over here from, for example, R2 minus R1 and our beloved R1 over here, and you will be left with G M M upon R2 equal to 1 by 2 M, it would be mass of planet itself, M V2 square into R2 plus R1 upon R1, which I can write it as follow: 2a upon R1 itself. Okay, now after comparing, I know that this is the kinetic energy. Okay, so I can say that kinetic energy at point 2 is nothing but will be equal to G mm upon R2 into R1 upon 2a, which I can write it as G mm upon R2 into R1 upon 2, or instead of 2a I can write it as R2 plus R1, and you'll be finding out why I am writing it as follow. Substitute this in the equation 1 itself and you will be having energy equal to G m upon R2 plus kinetic energy is replaced now by the following factor over here. Okay, simplify it further and you will be having this as your answer. Okay, cut R1 and R1 and you will be having G m upon R2 into minus R2 upon 2a. So the answer will be G m upon 2a. So guys, from this I can say that my energy, my net mechanical energy is inversely proportional to that of my semi major axis. So the question answer will be 5, which will be none of above. Okay, none of above option is correct among all these. Okay, now let us look at the following problem. A small body start falling onto the sun from a distance equal to the radius of the earth's orbit. Okay, the initial velocity of the body is equal to 0 in the heliocentric reference frame. Making use of Kepler law, you have to find how long will the body will be taking to be falling on that particular sun itself. Okay, how long it will be taking. So from the text itself, if you have got text from any prestigious institute, okay, you will be knowing that you are moving in a circular orbit around a heavenly body, okay, with some velocity v0, which we call as orbital velocity, guys. Okay, now if you are moving with a velocity less than that of orbital velocity, then you will be falling on that particular heavenly body as follow. Okay, in this particular curve, in this particular small ellipse curve. Okay guys, in this particular small ellipse curve you will be falling, but provided your velocity will be less than, very much less than that of that orbital velocity itself. Now your particular mass or your body is falling onto the sun as follow itself. Okay, so instead of following this circular path over here, he is following this small ellipse over here. Okay, and the matter of fact is that the distance is given to me as r, which is equal to the radius of earth orbit. Okay, it is equal to the radius of earth orbit. Now the fun fact is, while falling you will not fall in a straight line itself, you will be falling according to this particular curve. Okay, you will be falling according to this particular curve, which is elliptical. So time for this ellipse will be t. Now because you are falling from A to B, the time taken will be relatively equal to half of it. Okay, so time will be half of it. So then time will be half of whatsoever time you will be taking for this curve. Okay, so it will be 2 pi into a cube upon gm. Matter of fact is that my perigee distance is very much lower than that of apogee distance, so I can have this particular a as apogee upon 2, which is nothing given as radius of earth orbit itself. Okay, so 1 by 2 2 pi under root radius of earth orbit whole cube upon 8 gm of sun. Now the fun fact is that if you rearrange the following, you will be knowing that if I take this 8 out of the problem, I will be having 2 root 2 and I will be left with under root 2 pi radius of earth cube upon g mass of sun. Now this thing is nothing but the time taken by earth to revolve around sun, which is nothing but it is equal to 365 days itself. So you are having your answer as 1 by 4 root 2 into 365. So that's the answer. Okay, so guys, hopefully you have loved my lecture, liked my lecture. Please give it a thumbs up, like, share and subscribe my channel, and please hit the bell notification icon, share as much as you can, and please make this video to hit 100 likes. Okay, and I will be giving you more and more problems from Irodov which are very much important to you, which will be certainly coming into the examination in IIT JEE Advanced or IIT JEE Mains. So we'll meet you in the next lecture, guys. Until then, goodbye, guys.